Okay, hello everyone. Welcome to the lesson one, lesson two worksheet solutions. I'm going to be going through both of the worksheets and giving you some solutions to these. So we start off with two groups of data. We have categorical and numerical data, and then the two alternative words that we can use for categorical and numerical is qualitative, forgetting an I there, and quantitative. That. Cool. So those are the words I'm looking for. You can use categorical numerical. Just be warned that in the future, when you look at textbooks or read textbooks from different publications and universities, they might use qualitative or quantitative. Explain the difference between ordinal and nominal data, right? The nominal used for labeling / classification, where the values don't have order. For example, colors have no order compared to each other. And then we have ordinal, which is used for data that aren't necessarily numeric or measurable, but we can order them. Right, so they're not really numeric or measurable, but we can order them. Okay, so an example would be gold medal, silver medal, and bronze medal for Olympic athletes. Right, so we know that like these are non-numeric, but we know that there's a clear orders of value or almost like a magnitude within them. So gold is better than silver, silver is better than bronze. So those are the that's an type of ordinal data where we can categorize athletes based on what medal they got, and we would know that gold is better than silver, silver is better than bronze, and so forth. All right, next question. It says, explain the difference between discrete and continuous data. Discrete, often is, you can see it as almost finite, countable, whole numbers, positive and negative. Right, so can't be divided into fractional portions or be in a decimal. Okay, so an example of that would be, let's say, number of students in each grade 12 class. There shouldn't be any decimal based numbers. Each student in our grade 12 class, the number of students in grade 12 classes should be a whole countable number, whereas continuous can be infinite. It's very precise. You can use fractions, but more often uses decimals, where repetition of values are almost non-existent, and precision of measurement is required. Okay, so for example, this would be how fast a 100-meter track runner finishes their race. So in this scenario, like if everyone got 9 seconds, right, there will be no differential. We get into the decimal points, the exact value, and so we often call that a continuous numeric data, where we really need very precise measurements for each data that is recorded. Awesome. So those are our answers for that question. Perfect. Here we go. Population. Basically, the group or the group or the, well, we can say that it is the entirety of the source that provided or represents the study. Holistic. Oh my god, I can't spell. No, that's not what I'm looking for. Population often refers to everything, everyone, and every possible data value that can be studied for a statistical analysis. Right. So for example, we can look at population of every single person in Ontario, right? This would mean that we have studied and gained values from every living person in Ontario, which is very difficult to do. So often we don't use population. However, let's say, for example, if our study is just about grade 12 data management students in period 2, if everyone in that class responded to the survey, then we are doing a population-based analysis. Right? So depending on the study, the population can be very small because your criteria of getting all the population could be easy, like in our second scenario, but the first scenario is very difficult, where if you were to survey, question, meet every single person living in Ontario, that takes a lot of time and resources, and often we don't try to do something like that. However, asking the population will often give us the very best representation for our study and best data for our study. So we often, due to the intensive resources we need to get the population, we do a sample, which is a smaller subset of the population, so that we can study the population without seeing or recording data from every member of the population. Yes. And then if we're to define what a subset is a portion that has been derived or partitioned from a whole set of data, values, and let's say points. Okay. The word subset comes from the study of set theory, which is a study of mathematics where we describe groups of value and data, and we're going to talk about sets in the future. But since sample is a subset of a population, we can look at a population, and if we take certain number of values from the entirety of the population, we can call that the sample was a subset of the population. So we talked about sample and population. Sampling is a method of creating a sample, and we can say that sampling is important because studying the population is costly in terms of resources. A good sample is able to properly represent the population so that the statistical study can produce proper result reflecting the population. Right. So okay. So we do sampling because we want samples. Populations, analyzing the population is very costly. You have to talk to every single thing. You have to look at every single thing that's possible within the population, or talk to everyone that is part of the population. So if we have a good sample by using good proper sampling techniques, we should be able to still do a very effective statistical analysis study that will represent the population, even though we only looked at a little subset of the population. So that is the importance of that. Identify and explain one good sampling technique and one bad sampling technique. Explain your reasoning. We're going to look at simple random, where every member of the population has an equal probability, chance. Oh, I spelled probability wrong. Probability, chance to be chosen for the study, and you select, let's say, X amount of members for the study, and they all respond. Okay, so and then so we'll say this is the good one, and then we'll look at a bad one. We'll say voluntary, where the participants of the study only participated because they were willing to be a part of the study. Okay, so simple random based sampling is great because there is no selection bias, as in like how we selected the people. There's no let's say there's no bias in terms of the participants who gets to be involved in study. This allows a better representation of the population. Simple random based sampling is great because there is no bias in terms of the participants who get involved in the study. This allows a better representation of the population. Good. Voluntary is bad compared to simple random sampling because the data was heavily collected from participants who may be the only ones who care about the data, causing bias and skew in terms of the conclusions that can be drawn from the study. Okay, so simple random is good, voluntary is bad because it creates a lot of bias, because you have neglected the people who could have been very important data givers, but only the people that volunteered gave you the data, so it's very skewed. For example, like if you're doing a study on the importance of environment and climate change, and the people that are truly passionate about climate change and environmental impacts and sustainability, if only the people with those characteristics participated, your study might look like, oh, our entire population is really dedicated to environmental causes and they see a threat of climate change and whatnot, but that'll be very biased because people that don't care about climate change or the environment or whatnot, they just simply didn't participate in your study. All right, variability and status purpose. Variability. Is a measure of how far each data points are related to each other. It shows how tight or spread out the data is, and in certain scenarios, data that has less distance or variability will be a better data set to be used in such study. Will not be covered on the quizzes nor the exam, but we can look at risk assessment and quality control. So for example, if we look at risk assessment, like in finance and fields like finance, variability of returns is directly linked to risk. Higher the variability, investment returns often indicate a higher level of risk. In quality control, like for example in manufacturing, low variability in products, or like differences between products, dimensions, and quality is desired, indicating consistent production. So there you go. All day at the end. There you go. We're gonna learn how to calculate all these. We have range, interquartile range. So like we're going to do a variation of that. Then we have variance. Remember that variance isn't variability, but rather a type of or a method to calculate variability. And then we have standard deviation, which is also related to variance. One variable data, a data set that has a single variable studied. Example, the height of junior boys soccer team members in GWW. So single variable. Two variable data, a data set that has studied, that has recorded two separate variables, often one being dependent on the other to see relationships, correlation, and or causation. To study, let's say it's to study. Right. So obviously we haven't hit two variable yet because we're on this portion of our class right now where I'm just going to put this in a different section where we are going to study two variables later. So we're going to learn what relationship correlations and causations are, and we're going to learn what an independent and dependent variable is as well, and so forth. So let's classify the given data here based on, is it one variable or two variable? The ranking of participants in a school chess tournament. So I would say this is ordinal data that is a single variable. So we can say single variable ordinal data. Okay, number of students absent each class on Monday. That is, let's say, well, I don't need to write all that. Let's say this is a single variable discrete data, because because there's no 0.5 absences, and we don't need to categorize them. There's no sort of order. Okay. Customer satisfaction rating on a 5-point scale. So that's still single variable, ordinal data. 5-point scale. Yes. Student jersey numbers on the school basketball team. Each player has a jersey number. Okay. So can argue it is a two variable data, however, often can simplify as one variable data where we are pointing a player's name to their jersey number. Nominal data. Okay. The time it takes each runner to finish a 100-meter race, measured to the nearest hundredths of a second. This is discrete. I know this is continuous data. Single. The year birth of employees in the company, discrete data. And I don't think in this question you actually had to state that it's single or double because these are all basically single. Classify the sampling technique used based on the given scenario. A YouTuber asked people in a nearby coffee shop to share their opinion on the latest viral video because it is close and easy to reach them. So this sounds like convenient. If I can spell that correctly, perfect. Thank you. And let's go to this site here. A factory control manager checks every 15th item coming off the assembly line after choosing a random starting point. This sounds like systematic. Yes. All right. A TV news program invites viewers to call or text in their opinion on a proposed city curfew. Only those who feel strongly enough participate. So this is voluntary. A research team studying elementary school reading habits randomly select 8 school in the districts and test all grade 4 students in those school. This looks like stratified. Because it says for stratified, divide the sample into meaningful groups, then select from each group based on proportion. All right, so stratified only chose grade 4 students. Ratified. All right, classify if the following data or scenarios either one or two variables. Number of books each student read. So we're going to say this one variable. The height and weight of each, that's 2. Favorite color of each student in the grade, 1. The distance a runner completes and time it takes to finish them. So the distance and time. So we're looking at 2. The daily high temperature in a city. If there were multiple cities, this would be 2. But right now we're just talking about a singular city during the month of July. So this would be 1. The score each student receives on a math test is 1. The type of smartphone a person owns and their monthly bill, 2. The annual income of each household in a neighborhood. If it's a single neighborhood, 1. If it's multiple neighborhoods and their annual incomes, it'll be 2. But within this scenario, it is 1. Given the situations from A to H in the previous question, place the letters into the proper category. A, the number of books, that is... H, the height and weight, both could be continuous. Like if you go like 182.3 centimeters and like 62.5 kilogram. So this is arguably B, continuous, but you can also like say like a 6'2" and 200 pounds. So it could be discrete, but I think for measurements like that, you can be safe that is continuous. Favorite color of each student in a grade. Order doesn't matter, so we're going to say that that's a nominal data. The distance a runner completes and the time. Time is very specific. You might have to convert. Like it's really hard to record like hour colon minute, so you might have to translate that to like seconds or minutes. And the distance is, well, depending on like if they're doing set track distances like 100, 200, 400, 800, 1,000, 1,500, all that, or it's just like they just ran until they stopped or couldn't run anymore. That can provide very like decimal based data. So let's just say that's continuous. The daily high temperature should be precise. Let's say E. The score of each student receives on a math test. I like to give partial grades, so we're going to say F. For continuous, the type of smartphone a person owns and their monthly phone bill. The type of smartphone, that is nominal. So type of smartphone, that is nominal. But monthly bill has decimal values, so monthly phone bill. That will go there. The annual income of each household in a neighborhood could probably have decimals. Okay, so annual income. We'll do that. Major difference between one variable and two variable. With one variable, we often try to analyze frequency, how often certain values occurred, certain value occurred, its central tendencies, and we can also study trend and behavior if same type of data was collected over a period of time. Let's put that in a new page here. Okay, two variable data involves studying the cause and effect / relationship between the two variables that are studied. Okay. How does one affect the other, if at all? Perfect. And Google has caught all the corrections. Moving on. One variable data. Frequency. We can central tendencies. We can look at variability, which we'll call spread. And then, variables we spread, and so on. This is sigma, this is mu, this is x bar. To sum up all values within the data set given the start to finishing index, population mean symbol, and then this is a sample mean symbol. Cool. Explain how the data set should be formatted to calculate the mean. The data set should be a numerical data set that is sorted. Ordinal data can have a median. It is just the most central point when sorted as well, because ordinal data has order as well. Okay. It's different types of modes learned in class. So there's no mode. Every single data point occurs only once. Unimodal. One distinct value repeats the most. Bimodal. Two values repeats the most equally. And then we have multimodal, where, oh my lordy, 3 or more values repeat the most equal amount of time. Explain a type of value or values that could greatly affect the mean. Outliers affect the mean because mean is calculated as the arithmetic average, where we must sum up all the values in the given data. Yeah. Therefore, an outlier affects that sum heavily. Okay. Boom. For the following calculations, central tendency, explain their purpose when using it for one variable analysis. What did I say? Let me give you slide-based answers. Okay, we use it for numerical data, avoid for categorical. We can use it for when no outliers are present. The mean is used for other statistical calculations and such. It provides the arithmetic center of the data set, so that's its purpose. Median, it is resistant to outliers. It can be used for numerical and ordinal data. It is effective at splitting the data set into halves. it gives us the positional center. It gives us a quick frequency analysis of values that occur the most in a data set and can be used for all type of data. Very hard to use in continuous data set. Okay. All right, complete the following table: bar, pie, histogram, line graph. Oof. So we have it all here. This is the thing that you should put into here. So I'm not going to do that. Or, you know, I can also just do. Oh, it doesn't copy it. Yeah, just please refer to slide 35 of lesson 2. Let's put a smiley face. Oh. Boom. Okay. And the last question of this worksheet is for the given data set. We're going to determine the central tendencies. And I have it right here into the Google Sheet. So basically, in this type of scenario, you can punch it into Google Sheet, or you can use your calculator, just punch in all the values and make sure that you're doing the calculations properly. So in this scenario, we're going to say data set 1 that we have. We have data set 1 here. Let's zoom into like 150%. We have data set 1. All right. So we're going to write mean, median, mode, and then we're going to write the values here. So how to do mean on a Google Sheets. And we're going to have to do this because we need to use technology to analyze data, especially I don't want you to do this by hand in the future. We're just going to learn how to do it by hand for now. All right. So right now, I'm on column B and row 2 has all my data. And what I want to do is ignoring column A, all my data go from B all the way to whatever alphabetical letter that we're going to go towards the right. I want to take the average. The formula on Google Sheet to calculate the mean is called average. I don't know why they didn't just call it mean, but here we go. So we must calculate the average by writing equal sign, the formula called average, and you start the bracket because it is a function. And we're going to say that our input for our function is going to start at B2 and then analyze the entire row, the second row. So you just make it end at 2. That's going to give us a value of 72.12. Now, let's say, for example, the total sum is equal to, we can do sum function of B2 to 2, and that gives us 1803. And total count, we can say, we can count. You put an A, as long as there's a value in the data set, it means count any. It's going to count up how many values we have in the areas that we have inputted, which is 25. So the result would be this record divided by this record, which gives us 72.12. All right, so we just double check their work. Perfect. For the median, you can write median. There is a median function, and you provide the input for data set 2, data set 1. So we're going to go B2, 2. That gives us 72. Hey, there is not a good, there's not a big difference between our mean and median, which is great. And then we can do mode. There's multi and single. We're just going to try mode here, B2, 2, and 62 occurs the most, which occurs 3 times. Okay. Let's look at data set 2. We're going to look at mean, median, mode. It's going to be the same thing. So we're going to say average. And we're going to go from B3 to 3. And that gives us 117.375. For median, we go median is equal to data set. So B3 to 3. That gives 117 once again. The distance is not too high. And then we're going to go mode B3 to 3, which is 106. 106 occurs the most right there. All right. Then we look at data set 3. Average is equal to B4 all the way at the end of the 4, 32. Let's look at median, which is going to be B4 to 4, and then mode B44, and it says non-existent because there is no multiple value. There is no two values that occur more than once. So let's see. Yep, it doesn't seem like it. Perfect. All right, so those are our answers for our last questions where we are determining the central tendencies by calculating the mean, median, and mode. I hope you enjoy the solutions. I hope that you have a good day. Stay classy and see you next time.